Hello, my name is Anton, I will guide you through this tutorial. In this tutorial we are going to program the UART communication between DE1 Altera board and computer. This bidirectional serial communication allows you to send and receive data, control your FPGA through PC and so on. We will also take a look at how to use components in your VHDL design. Let's start. First, include standard logic and numeric standard libraries. Next, declare entity. We are going to use 50 MHz main clock, switches, keys and lots of green and red LEDs. The UART consists of two ports, the transmission line and a reception line, both of type standard logic. At this point I will briefly summarize how does UART function. The transmission line consists of just one single wire. While the line is idle, it holds high state. If it's going to send data, the state goes low, signaling the start of the transmission. That's why the first bit you have to send is called start bit. After the start bit you send your 8-bit data, as the high state of the transmission line is corresponding to the logic 1 and low to 0. After 8 bit of data, the transmission is finished by the stop bit, which is logic 1. The line keeps the state until the next communication. So each data package is 10 bit long, 8 bit of data plus stop and start bit. As your FPGA project is getting bigger and more complicated, it's advisable to separate the code in several discrete functional parts. In VHDL it is done by using components. In this tutorial we are going to write the receiver and transmitter as components and include them into our top entity. Okay, the entity is done, now let's program the transmitter. Open new VHDL file. Add the libraries first. Now write your code as if it's your main file. Start with entity. For the transmitter we will need 50 MHz clock source, a start signal which will start the transmission, the busy signal which will indicate if transmission is currently running, the 8-bit vector which we are going to send, and eventually the actual transmission line which goes out of our FPGA into PC. In the architecture, we will need few signals: the prescaler for the main clock, the index to select which bit we are going to send, and the data full vector, which consists of 8 bit of data plus start and stop bits. the signal TX flag will start the transmission process. The new transmission starts only if no communication is currently running and the start signal is high. Only if both conditions are true, we set transmission flag to 1, read data and place it into the data full vector between the start bit and the stop bit. Okay, now transmission flag is set to 1, we start sending data. Since the common data rate for UART is 9800 bits per second, let us build a simple prescaler which counts to 5208. This will give us the desired bit rate. Good, if prescaler hits 2800, pass the transmission line the current bit and increase the bit index by 1 if it is less than 9. If it is already 9th bit, the last bit is sent and the transmission is complete. At the end of transmission, we set the transmission flag, index and the busy indicator. The transmitter component is done. Now we add it into the top entity. First we declare the component in the declaration part of the architecture between is and begin. Write component and then list its ports as they are declared in the description. You can simply copy-paste this part. Next we have to connect the component to the main entity. This is done by port map. First you label the component, for example C1, then write the X port map. In brackets specify which signal of your main entity connects to which port on your component, in the same order as they are listed in the component declaration. For example, the clock is connected to the main clock 50, the X line to UART XD, and so on. Signals for start, busy and data don't exist yet, we will create them in a minute. Okay, let's declare the missing signals. Great! All is left is to write a simple process that will read first 8 switches and set their status as 8-bit binary number to PC. The transmission is only triggered if key is pressed and the transmitter is not busy. The green LEDs will show the number in binary on the FPGA board. Sure, while holding the button the FPGA is sending about 980 packets per second. That is why I receive many packets at once. Nice. Now let's program the receiver. For new component, we take new VHDL file. The receiver is somewhat similar to the transmitter, it's just working in the opposite direction. It also has main clock, 8-bit data output, busy indicator, and of course the reception line and RX line. We will also need a prescaler, bit indexer and RX flag, which starts the reception process. Okay, the reception starts if no communication is active and RX line is low, that means start bit is detected. If both conditions are true, initialize prescaler and index, also set RX flag and busy indicator to 1. While the reception is running, assign the value of Rx line to the corresponding bit in data full vector. Each time the prescaler hits 2800, increase index by 1. If index is equal to 9, then the reception is complete. In this case we check if the first bit is equal to 0 and the last bit to 1, just to make sure we don't have any frame error. If everything is okay, pass a bit to data. If not, fill data with zeros. Now add new component as we did before. Next, map ports. Finally, let's add the process which you assign and receive the data to the first 8 red LEDs. The assignment is executed on the falling edge of the busy signal, that means as soon as the new data is available.